So for some use for summations, for the first one, I'm gonna prove it. So for the first one right here, we have sum of geometric progression. So if I have sum of j, will go from 0 to n, and since it's geometric progression, so we have our initial value a times a common ratio r, and to the j's power. So right here really just means I'm gonna have a times r to the 0 plus a times r to the first power plus a times r squared plus da 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 until we get a times r to the nth power. So which is a plus ar plus ar squared plus da 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 to plus ar to the nth power. So for my formula for this one right here is, now my summation of arj will equals to, now if my ratio is equal to 1, now as you can see right here, if the ratio is equal to 1, then I will have a plus a times 1 plus a times 1 squared plus da 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 a times 1 to the nth power. So really just gonna equal to a plus a plus a plus da 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 plus a. Now this one right here, we're starting with 0 and then we end up with n. So we're starting with 0 here and then we end up with n term. So that's why right here I will have n plus 1 terms of a. So I will have a times n plus 1. So that will be my formula if my ratio is equal to 1. So it'll be a times n plus 1. Now if r is not equal to 1, and that'll become interesting formula. So which is a times r to the n plus 1 minus 1 over r minus 1. Now how do we get this formula? That's the one I'm going to try to prove. As following. So we're gonna let s. So I'm gonna let s of n right here represent for sum of the sequence. So s of n here is equal to summation j from 0 to n and a times r to the j's power. So my s of n here is equal to a plus ar squared plus ar cubed plus da 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 plus ar to the nth power. And now I'm gonna multiply by r for each side. So I will have r times Sn, which is equal to a times r plus a times r squared, because each term I'm going to multiply by r now, plus ar cubed plus ar4 plus arn, and then well, dot 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 to arn, and then plus the last term, we have arn, so if arn times r, that should be ar to the n plus 1. The reason why I'm doing this right here, I'm going to call the first function right here, I'm going to call this as a 1. And I'm going to call the second function right here is 2. And then I'm going to do 2 minus 1. So second equation minus the first equation. So if I do that here, now my AR and AR will be canceled. AR squared and AR squared will be canceled. AR cubed canceled. And all the way to ARN to ARN canceled. The only thing left right here will be AR to the n plus 1. And then A for my right hand side. So I will have r times s to the n, r times s of n minus Sn will equal to ar to the n plus 1 minus a. So I'm going to factor out s of n here, and I will have r minus 1 will equal to a times r to the n plus 1 minus 1. And then to solve for s of n, I'm going to divide it by r minus 1. So the s of n is equal to a times r to the n plus 1 minus 1 over r minus 1. So this is how we got a formula in our geometric series right here. All right. And also here, another very important formula is if your ratio is, let's just in general put the absolute value right here. If your ratio is greater than 1, and now I'm not going to have the n as my final term, I'm going to have infinity. So I'm going to have j go from 0 to infinity, a times rj. So which means I'm going to have a plus ar plus ar square plus ar cube plus dot 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 all the way and non-stop. So now in this case, if my ratio is greater than 1, and then also my n is going to infinity, so that will make r to the n plus 1 right here is going to infinity, which means my s of n, if you learn the calculus, the Sn right here means Sn is diverging. So which means there's no solution for S. No solution for the sum. But if I change my ratio, absolute value of ratio is less than 1, so and n is going to infinity, then the things change. Because if r is going less than 1, and then your r is going to n plus 1. So for example, you can think of 0.5. 0.5 to a really, really big number like 1,000. So this one right here is actually going to approaching to 0. So my r to the n plus 1 is going to 0. So my S of n right here will equal to a times 0 minus 1 over r minus 1. So that will give us the second very important formula, which is S of n is equal to a over 1 minus r. So for the second formula, still is infinite geometric progression is here are some conditions you have to satisfy. The first one right here is r has to be less than 1, absolute value r has to be less than 1, and also your sequence right here will be j go from 0 to infinity. All right, so it has to go to infinity. So for a times r to the j's power, then that will just equal to a over 1 minus r. Right, so now for example, if I have a function or sequence right here, j will go from 0 to infinity. And then I'm doing 3 over 4 to the j's power. And now look at 3 over 4. So since 3 over 4 is less than 1, so that's why right here, I will using my formula directly. My initial value is equal to 1, because right here, this is like little 1 right here. So my initial value is going to be 1. And then my ratio is 3 over 4. So it'll be 1 over 1 minus 3 over 4, which is 1 over 1 over 4. Then that will equal to 4. Now, similarly, if you have the negative, it's the same idea. So if I have sigma of j go from 0 to infinity, and I have negative 3 over 4 to the j's power. So still the same, your initial value is going to be 1. So then right here will equal to 1 over. Now 1 minus, so if you do absolute value of negative 3 over 4, that's still going to be less than 1. So we're going to have 1 minus negative 3 over 4, which is equal to 1 over 1 plus 3 over 4. So then that'll give us 1 over 7 over 4, so which is 4 over 7. All right, so if you have a negative value, it will be the same idea. So another example is if you have summation, j go from 0 to infinity, but we're going to have 4 to the j's power and plus 3 to the j plus 1's power over 5 to the j minus 1's power. So for this question right here, now it looks very complicated, but let's just separate them into two different fractions. So then we're going to have j go from 0 to infinity, 4 to the j's power over 5 to the j minus 1, and plus 3 to the j plus 1 over 5 to the j minus 1. So in this case right here, now I want to keep them to be the j, all right, because my j started with 0 and go to infinity, so which is perfect. I don't really want to change it. So now in this case, I'm going to rewrite my 5 to the j minus 1 power into 5 to the j times 5 to the negative 1. And now similarly for the 3 to the j plus 1 right here, I'm going to do 3 times j times 3 to the j's power times 3. and over 5 to the j times 5 to the negative 1. And I'm gonna have simplify that. So it'll be 4 to the j over 5 to the j, and then times, well, 5 to the negative 1. If you bring to the top, then that should be times 5. And now for this one right here, now 5 to negative 1, same thing, gonna bring to the top. So then that'll become 3 to the j over 5 to the j times 15. So if we put them together, we're gonna have 5 times summation, j go from 0 to infinity, 4 over 5j, or you know what, let me just put a 5 inside. And plus, now I'm gonna separate them into a second summation. So it'll be j go from 0 to infinity, 15 times 3 over 5 to the j's power. And now from here, I know my initial value. This is a, my initial. And then this is my ratio, and this is my second ratio. So I'm gonna call R1 and R2. So my 4 over 5 is less than 1, 3 over 5 is less than 1, everything's good. So I'm gonna have 5 over 1 minus 4 over 5. That's for my first summation. And for my second summation will be 15 over 1 minus 3 over 5. So then that will equal to 5 over 1 over 5 plus 15 over 2 over 5. So then that will equal to 25 plus 75 over 2. So which is equal to 125 over 2. Okay. And then if you would like to try a practice. So we're going to do summation, j go from 0 to infinity. 4 to the, oh, you know what? Let's just do the practice at the end. All right, so I'm gonna finish up with other summations, the important summations. So for second summations right here, we'll have summation will be k go from 1 to n and then k. So really in this case right here means I'm gonna do 1 plus 2 plus 3 plus 4 plus all the way to n here. So this is equal to n times n plus 1 over 2. Now, one of the example we have is 1 plus 2 plus 3 plus 4 plus 5 plus all the way to 100 will equal to 5050. So the reason why we got 5050 is because we recombine them. So we do 1 plus 100, and then we do 2 plus 99, 3 plus 98, 4 plus 97, and then keep going. And then there are 50 pairs, right? Because each time we take out 2 numbers, there'll be 50 pairs, and each one is equal to 101. So that's why we're going to do 50 times 101, which is 5050. That's how we got this formula, right? And for the next formula here, we have summation, k go from 1 to n, and then the k square, which is equal to n times n plus 1, times 2n plus 1 over 6. And then the fourth one right here will be summation, k go from 1 to n, and then k cubed. This is going to be n squared times n plus 1 squared, and then over 4. So we're going to using those useful summations, right? So for example, if I have, we want to find summation will be k go from 5 to 10 and then k squared. So for this question, of course, you can do 5 squared plus 6 squared plus all the way to 10 squared. That's fine. But if I change that into like 5 to 100, then that will become a little bit more difficult to do. So now in this case, now this is what I'm going to do here. I'm going to use my number 3, which is the summation k go from 1 to n, and then k squared, which is equal to n times n plus 1, 2n plus 1 over 6. So I know that I'm going to do 5 to 10, right? So now, well, you know what? Let's just try the 5 to 100. So if I want to do 5 to 100, I'm going to have many terms. But if you look at your this formula right here, you k start at 1. you cannot start at 5. So what I'm going to do right here is I'm going to find the sum between 1 to 100. So between 1 to 100. So I'm going to do this sum. And then if I'm looking for 5 to 100, so you can have 5 to 100. So if I'm looking for 5 to 100 right here, now I can use 1 to 100 and then subtract this 1 to 4 right here. If I do 1 and then subtract the 4, 1 to 4, then I will get a 5 to 100. So that's why in this case, if I do k go from 5 to 100 k squared, I can just do k go from 1 to 100 k squared. So I got the entire 1. So this is my k go from 1 to 100 k squared. And then I'm going to subtract. So I'm going to subtract this part. So which means I will do k go from 1 to 4 and then k squared, right? So then that will be 5 to 100 left. So now if I do 1 to 100 k squared, then I can use my formula directly, which is 100 times 100 plus 1 times 2 times 100 plus 1 over 6 minus 4 times 4 plus 1 times 8 plus 1, right? 4 times 2 is 8, right? Over 6, all right? So then the first number that will give you is 100 times 101 and times 201. And then we're going to divide it by 6. So the first one is equal to 338,350. And my second one right here will be 4 times 5 times 9. And then divided by 6, which is equal to 30. So we're going to have 338,320 as our answer, right? So now for our practice, you can try these 2 questions. For the first question is if I want to do summation, j go from 0 to infinity, 4 to the j minus 1 over 5 to the j, let's do plus 2 right here. And then for the second one, let's try summation, k go from 7 to 30. 7 to 30, and then k cubed. All right, so similar idea. You can find your answer in the description box. And all right, and before you look at the answer, make sure you try them.